All right, so here I've got two final questions that I kind of want to go over. They don't happen to be on the take home test, but they were a little weird. And so I just wanted to take a look at them just for the sake of, giving you guys some more information on this topic, on this unit. So let's take a look. Question 10 in the review packet. If f of x equals 3 to the power of x and g of x equals 2x plus 5, at which value of x is the function f of x smaller than the function g of x? So it's a little confusing at first, but all I'm doing is putting in different values to x until I find one that's going to make f of x less than g of x. So let's try over here. If I try 3 to the power of negative 1, well, what is that? I don't know. Let's throw in the calculator and take a look. Boom, boom, boom. 3 to the power of negative 1. Sorry, I don't have the fancy calculators right now. 3 to the power of negative 1 is 0.3 repeating. 0.3 repeating. Boom, boom, boom. And then let's try out this other one. For g of x, it's going to be, it's going to be 2 times negative 1 plus 5. 2 times negative 1 is negative 2 plus 5 is 3. Well, in this case, it looks like f of negative 1 was 0.3 repeating, and g of negative 1 was 3, and 0.3 is less than 3, so it looks like this is going to be the case. It looks like answer choice 1 is correct. If I try 2 here, I'll get 3 squared, which is 9, and 2 times 2 plus 5 is also going to be 9. These are equal. Nothing's less than the other, so it's not 2. If I try 3 to the power of negative 3, if I try that out, let's check that one in the calculator. 3 to the power of negative 3, I end up with 0.37, so maybe that's going to be it. But then watch, if I try, 2 times negative 3 plus 5, I end up with a negative number. So here f of x was bigger than g of x, so it's not that. And if I try this one over here, 3 to the power of 4, is that less than 2 times 4 plus 5? 3 to the power of 4 is some big number. 3 to the power of 4 is 81, where here I only end up with 8 plus 5. I only end up with, 13? This is not true either. Here f of x is not smaller than g of x, so answer choice 1 is the correct answer there. Let's take a look at one more kind of weird one. Right, we already looked at that one. Let's take a look at this question right over here. I want to look at actually just this bit on the bottom here. So it says, let f be a function such that f of x equals negative 2x minus 4, and it's defined on the domain from 2 to 6. It is defined on this domain from 2 to 6, including 2 and 6. It's then asking, what is the range of this function? So that gets kind of weird, because you can't just get the range of this function in general. You should only be able to get the range of the function between 2 and up till 6. So let's try a couple of those numbers in there and see what happens. I'll give my x's and my y's. Let's even do, it's not going to be that crazy if I do 2, 3, 4, 5, and 6. If I start filling this table out and figure out what my y's are going to be, it should start giving me information about my range. So 2x minus 4 when my input is 2. This will become 2 times 2 is 4, minus 4, my output will be 0, right? 2 times 2 minus 4, I end up with 0 over there. Let's try it as 3. 2 times 3 is 6. 6 minus 4 is 2. Let's keep going here. 2, I'll get an input of 4 this time. 2 times 4 is 8, minus 4 is 4. 2 times 5 is 10 minus 4 is 6. 2 times 6, my input is 6. 2 times 6 minus 4, this will get me 12 minus 4 is equal to 8. So I'm just doing this math really quick in my head to get the matching outputs. 8. It looks like my range when my inputs are here are going to be any number between 0 and 8, which happens to be answer choice 1. So given this function restricted to this domain between 2 and 6, here's my range. I could have done decimal numbers too, but it's going to end up being just between these numbers. So those are the last kind of weirder ones I wanted to talk about, and that's it for Unit 4.